Hello, my name is Ashish Dubey, working as an assistant professor in the Department of Civil Engineering, MIT Mysore. So, in this session, I will be taking up the subject Introduction to Civil Engineering, wherein I will be discussing in detail about the module number 4, which is Centroid. Introduction to Civil Engineering with the subject code is BESCK 104A or 204A. So, that depends on in which semester you are taking up this subject. If you take this in the first semester, the subject code will be BESCK 104A, and if you take up this subject in the second semester, the subject code will be BESCK 204A. Okay, and module 4 deals with Centroid. In the previous module, you might have come across the force system, classification of force system, and then the moment and couple, etc. In this module, we shall try to understand how to locate the centroids of plane figures. But before moving on to that, we shall know what is centroid. To know what is centroid, we need to understand what is center of gravity. Okay. If you have a body without mass or the mass is negligible, then we cannot locate its center of gravity. We do not call it as center of gravity, instead we call it as a centroid. Okay. So, if I take this as an example, so this is a book having dimensions, length, breadth and its thickness, you can see easily, right. So, this looks like a rectangle, it is having a rectangular shape. Now, this will be taken as a 3-dimensional object. Okay. So, for this body or an object, we can easily locate its center of gravity because it is having mass. But if we consider only a single sheet of paper, say single sheet of paper, it is also having the same dimensions of this as of this book, but this is having thickness very less compared to the entire book, which can be neglected. It is having a negligible weight. Now, if I ask you to locate its center of gravity, it is not possible because it is having no mass. Now, you know what is a moment. Moment is nothing but force into its perpendicular distance. Similarly, centroid is also given by the product of moment and its area. I mean to say, if you take the moment about the axis, that is the centroidal axis, then the moment about that point will be equal to 0. Okay. So, if I take a rectangle which is a 2-dimensional figure. Now, I will locate the centroid here, which can be denoted by the letter G, and it has to be represented with the help of its coordinates, say x bar and y bar. But on what basis can we say that this is the point where the centroid can be located for a rectangle? So, by just looking at this figure, you might have an idea. You might think that it is exactly at center, it can be located easily exactly at center, but no. It is the point where the diagonals of the rectangle meet. One diagonal and the second diagonal. See, it is the point where the diagonals of the rectangle meet. So, this point is called as the centroid, and it is always represented with the help of the coordinates. Okay. So, if I take this as the origin O and this be represented as x axis and this be represented as y axis. So, this G is nothing but the centroid that defines the position of this point with respect to OX and OY axis. Okay. So, this is nothing but the horizontal distance x bar and the vertical distance y bar, which is represented in the coordinate system. So, always this centroid should be located with the help of the coordinates with respect to the origin. Okay. So, centroids can be located for geometrical figures. Now, if we take up a triangle, so for this triangle, where can we locate the centroid? So, here it was a rectangle, and then by intersecting the diagonals, we can say that wherever the diagonals are meeting, that point can be categorized as a centroid. But in this case, triangle, where can you locate? This is the point which is G of x bar comma y bar. Okay. So, for a triangle, this is the point where the centroid lies, but you do not know what is this distance. So, if you take this as a base and this as the height of the triangle, you cannot say that it is exactly half of the height or half of the base. No, it is not right. We need to determine that. So, now let us understand what is center of gravity and a centroid. So, I have written the definitions of the same. Center of gravity is denoted by Cg and centroid is defined by the letter G. Now, what is center of gravity? The center of gravity of a body is that point to which the resultant of the system of parallel forces. See, now you know how to locate the resultant or determine the resultant of the various forces from the previous module. Okay. So, it is the resultant of the system of parallel forces formed by the weights, very important, weights of all the particles of a body which passes for all positions of the body, which passes for all position of the body. This is nothing but the center of gravity. It is the center of gravity of a body is that point to which the resultant of the system of forces, all the parallel forces formed by the weights of all the particles of the body which passes for all positions of the body. So, if you see this figure and try to imagine this is a body having mass, that is denoted by W, that is nothing but weight. This center of gravity can be located as this point, that is CG. So, now let us understand what is centroid, which is denoted with the letter G. See, centroid is applicable only for geometrical figures. The body which is having mass has the center of gravity, but for a body having no mass, we can locate the centroid. Okay. So, geometrical figures, all the geometric figures do not possess the property of weight. So, the geometric figures such as triangle, rectangle, square, circle, semicircle, etc. centroid of an area, see, center of gravity will be defined for a body having mass, but centroid is determined or located for an object having an area. Okay. So, here we are concentrating on the area because it is having no mass. Okay. If an area is that point through which the centroid of all the component areas, means if you consider a area, geometrical area, that can be having number of components in it. So, if you take a bigger area, that bigger area is composed of number of smaller areas, that is are smaller components. So, we need to divide the bigger area into smaller components, okay, and then of all the components passes through the centroid and is also defined as a point in plane area such that the moment of the area about any axis passing through the centroid is always 0. This is very, very important. Okay. So, centroid is nothing but it is always located for a geometrical figure. So, this geometric figure do not possess the property of weight. The centroid of all the component areas passes through the centroid, also defined as a point in a plane area such that the moment of the area, see here we are not talking about the moment of a force, it is the moment of the area passing through the centroid. Passing through the centroid is always 0. So, let me write a separate figure so that you will understand this statement clearly. So, if I take a geometrical figure of unknown shape and let me mark this point as the centroid G, and this will be now taken as x axis and this will be taken as y axis. Please observe, x axis and y axis are the axes that are passing through the centroid. So, from this definition, the moment of an area that passes through the centroid is always 0. So, if I take a section line say 1 1 or if I take another section say 2 2, from the definition we can say that the moment of the area about the point 1 1 which is passing through the centroidal axis is equal to 0, or even if you take the moment about the section 2 2 which is passing along the centroid or the passing through the centroid, we can say this is also equal to 0. So, if you try to take the moment of an area with respect to its centroid, then we can say that it will be equal to 0. Moment of an area that is passing through the centroid or the centroidal axis is said to be 0. Okay? Clear? So, this is always taken up only for the geometrical figures or the plane figures. Now, let us try to understand how the centroid of an area is calculated. To determine the centroid of a plane area, So, for this axis is very much important, coordinate axis is very much important, and let us imagine there is a area whose centroid is G and it is represented as G of x bar comma y bar. Let me plot it in the figure. So, this will be the x bar component and this will be its y bar component. Now, how do you try to determine the centroid of this particular area? So, as you are now aware about the definition of the centroid, what we need to do? We need to divide this into number of components or the component areas. So, if I take this figure, its area will be capital A and its centroids or the coordinates of the centroid are x bar and y bar. Coordinates of the centroid is x bar and y bar. Similarly, if I consider smaller elements here, say let me consider an element here whose area is said to be dA1, and let me consider one more area whose area is denoted by dA2. Now, what about its x and y components? Similar to this, plot it and you can write it as x1 and y1. Similarly, the centroid of this second area can be taken as or marked as x2 with respect to y axis, and this will be y2 with respect to x axis, this will be x2 with respect to y axis. I hope you have understood this. So, what I have done is I have taken an area and I have marked its centroid and its coordinates G of x bar comma y bar. that is x component is measured from y axis, y component is measured from x axis, and capital A is said to be the entire area of the component. And now I have divided this into number of components, and I have only considered two smaller areas dA1 and dA2, whose x and y components are as shown in this figure. So, the x1 is measured with respect to y axis, y1 is measured with respect to x axis. Similarly, for dA2, x2 is measured with respect to y axis, y2 is measured with respect to x axis. Okay. Let us divide the area into smaller areas, say A1, A2, A3. Sorry, let me change this as small A2 and this as small A1. Smaller areas A1 and A2, comma A3, etc. as shown in figure. Let x1 comma y1 comma x2 comma y2 be the coordinates of this centroid, be the coordinates of the centroidal areas A1, A2, A3, etc. So, x1, y1, x2, y2 are the coordinates of the areas A1, A2, A3, etc. Okay. With respect to origin O, it is very much important. Next, algebraic sum of moments of the elemental areas about an axis is equal to moment of the whole area about the same axis. Okay. That is A into x bar, that is the product of the area into its x component, which is x bar, is equal to capital A is the area of the entire component, capital A, whereas small a1, small a2 are the smaller elemental areas, is equal to a1 x1 plus a2 x2 plus a3 x3 plus etc. So, from this equation I shall calculate what is x bar equals to. So, x bar is equal to a1 x1 plus a2 x2 plus a3 x3 whole divided by capital A. But what about capital A? Capital A is nothing but the summation of all the small elemental areas. It can be written as a1 x1 plus a2 x2 plus a3 x3 plus etc. divided by a1 small a1 plus small a2 plus small a3 plus etc. This is the formula for x bar. Okay. But when we take up the numerical problems in the coming sessions, I will be using capital A1, capital A2, capital A3 and capital A1, capital A2, capital A3 in both numerators and denominators. Okay. So, please be careful. I am writing only for this particular step as small a1, small a2, small a3, but in the numericals I will be writing it as capital A1, capital A2 and capital A3. This is the formula for x bar. Similarly, if we take up algebraic sum of all the areas and the moments with respect to the y component, we get A into y bar is equal to A1 y1 plus A2 y2 plus A3 y3 plus etc. So, y bar will be equal to A1 y1 plus A2 y2 plus A3 y3 etc. by capital A is nothing but the summation of smaller areas, that is A1 plus A2 plus A3. So, this is how you calculate the centroidal components of given area. So, now let us move on to the next concept, which is the axis of symmetry. Okay. So, what do you mean by axis of symmetry? It is the axis which divides an area into two equal parts in such a way that one part is equal to the mirror image of the other. I hope you have understood about the axis of symmetry. Now, let me take some examples so that you will understand the axis of symmetry very easily. Let me name this figure number 1. Now, figure number 2, figure 3, figure 4, figure 5. So, now if I take these 5 figures as an example to explain about the axis of symmetry, it will be very beneficial to you with the help of the figures. It is nothing but the axis which divides the area into 2 equal parts in such a way that one part is equal to the mirror image of the other. Now, if I take up the first example and try to draw any axis of symmetry if possible, then so just looking at the figure, we can say this figure is symmetrical about x axis, but it is not symmetrical about y axis. Why did I make this statement? Because if you cut it along x, one part is equal to the mirror image of the other, but if you cut it along y axis, you will not be getting the same mirror image on both the sides. So, in figure 1, we can say it is symmetrical about x axis only. Coming to second figure. Now, you just need to draw a line so that you get a mirror image of the other. So, where can you cut that line or an axis? So, here if you cut it along the axis y, we get an mirror image on both the sides. So, one part is equal to the other part, that is it is symmetrical about y axis, and if I try to locate its centroid and draw the centroidal axis, so this will be its x axis, and if you cut it along x, will it be symmetrical? No, you are not going to get the mirror image of the other. Hence, it is symmetrical about only y axis. It is symmetrical about y axis only. Now, let us take the third example. Now, try to cut this figure so that we get the axis of symmetry. We should check whether we get axis of symmetry or not. So, if I cut it along y axis, this one part is equal to the mirror image of the other, and if I cut it along x axis, observe here. So, this part also looks like the mirror image of the other, yes or no? So, what we can say in this figure, it is symmetrical about both x axis and y axis. So, in this figure both the axes are symmetrical. Now, coming to figure 4. So, if you try to locate its centroid with the help of a axis x and y, we can easily say that this figure has no symmetrical axis. Do you find any symmetrical axis even if you cut it along x or y? No, we are not getting any symmetrical axis. Therefore, what we can write? No symmetrical axis. Now, coming to the figure 5, it is symmetrical about only y axis, but it is not symmetrical about x axis because it is not giving you the equal mirror image on both the sides. So, here we can say it is only symmetrical about one axis, that is y axis. So, it is symmetrical about y axis only. So, these examples will give you a clear picture on how the symmetrical axis can be drawn, and how do you write the symmetrical axis and say that this is the symmetrical axis as it cuts this into two equal halves. Whether a given plane figure has the axis of symmetry or not can be easily determined with the help of drawing the symmetrical axis. I hope you have understood the axis of symmetry. Okay. Next, we shall derive the centroidal components of plane figures. Okay.